formula? From A to B, pi r squared. So the only reason I put that r in the brackets is so that you know that that's going to be the function you're looking for. That's where we're going to do that top minus bottom, right minus left. So horizontal axis of revolution, so that's revolving around anything that way. That's revolving around anything that's going to be vertical. So x-axis versus y-axis type problems. Your volume, you're just going to set it up the same way that you already know, up there. And the only difference is, actually, let me write this here. Instead of using a and b, let's use x1 and x1 and x2, so that we remember that those have to be x values. In here, call it r of x, so we remember that those have to be x values, and then dx. And then same thing for the y. I want this to be a y1, this to be a y2, so we remember they have to be y values. And then pi r of y squared, and then dy. So formulas all look the same. You've already done it. I'm just being very specific to say I want to make sure you remember these should all be x's in here, and these should all be y's in here. Okay? So now let's revolve some things. Sketch the function. I can believe it's sine of x. And then when you do your revolution, draw the axis of rotation for me. And then I usually do a little circle that shows that that's where I'm going to revolve. Without me drawing it up here, what shape will this end up making? Definitely not a sphere. An ellipsoid. Looks like a football. Well, we can't use descriptive words. Football. Definitely not a shape of a circle. That will not make a circle because this is not a semicircle. Okay, it's going to look like a big fat football. If you want to know what they look like, if you're curious how it looks, I actually never draw the image because I think it gets confusing in my picture, but I will draw it once for you. Reflect across the axis of rotation. You can physically see the two-dimensional shape, and then if you're curious what the cross-section would look like, anywhere along here, you would create a circular cross-section. So obviously there, the area of your circle would be pretty small. Here, it's getting bigger. So that's what it would look like if I drew the whole entire shape. I personally do not. I think it makes my image look a little messy. But some of you like seeing the 3D shape. That's how you would see what it looks like. I'm going to backtrack and get me back to the original that I had. So, once you have your graph, you've highlighted your axis of rotation, then you're going to give yourself that segment that helps us figure out is it dx or dy, and then it helps us figure out top, bottom, right, left. So the way that we draw that, from the curve, anywhere on the curve, go towards the axis of rotation. So I see that this is a vertical. Vertical means that this was the top and this was the bottom. So now I know this is a dx or a dy. It's definitely a dx, so it follows area. Everything you knew about area is still the same. So if I know that this is a dx, so let's start off with volume equals. Dx means I need a domain. The lowest x value this image uses, 0. The biggest is pi. And then from there, I would need pi r squared, and then we're going to set up our r. Remember the image that I showed you? The circle went from all the way up here, all the way down here. So this top and bottom is actually the radius. Different from if I tell you the image is a semicircle. Okay, so that's a little bit different. So that's your radius. Can you guys fill out the rest of the volume? easy, right? Because it was a nice, easy function. Your top function was sine of x. Your bottom function was just 0. You don't have to worry about that 0. If you don't write it, it's not wrong. You're allowed to simplify that out. Okay, any questions on this guy? Okay. Revolutions mean circular cross-sections. Okay, any other time, you got to follow the shape I give. That's why we did all the shapes first. Looking at the second one, now I'm going to do one that's not the coordinate axis. So it says find the volume of the solid. We're going to end up revolving around this line. So go ahead and draw in y equal to 1. That's the axis of revolution. I want to revolve to, I believe this is the shape. And these are what I call solids. What I mean by that, this is also going to create a football. There's no air inside the football. It's going to be a completely solid shape. Meaning I am revolving this filled-in area about that line, the axis of rotation. So same setup. I would like you to draw from the curve to the axis of rotation. Start there. Label that right, left, top, bottom. Figure out your volume formula. Which means you need to figure out, is it a dx, dy, and so on. Okay, so draw from the curve to the axis of rotation. Do not stare. Draw. I need to see that segment on your papers. I don't want to see that skipped at all. So I can see some of you do not have it, so please draw the segment. Yeah, it's hard to see it. Jamie, dx or dy? Dx, let's see. So one more time, just to make sure we remember that there is the actual radius of the picture. Travis, top function. What was the top function of this guy? 2 minus x squared. And what was the bottom function of this guy? It was y equal to 1, but 1 is correct. There's your radius. Now that I have my radius, I know it's a dx because I was just told it was dx. So Janet, what are my limits? -1 to 1, and then pi r, which is right here. I'm not going to even simplify it in terms of how I'm going to put it in here, but when you integrate, you can simplify it. So just like area, okay? Just like area, you're still doing your top minus bottom, right? Say that one more time. I don't understand your question. It doesn't say that anywhere here. Hypothetically, ask me after class because I'm still very confused in what you're asking me. All right. Revolving around the y-axis. This one, I actually described the area really badly. So I'm going to show you the area that I want you to revolve, okay? So in this case, I would like you to revolve, I believe. So this is shifted to the right. This is the area that I want you to revolve. If you want to do a part B, you could actually revolve. You could revolve it about there too. Both of these actually work. So this one I want to revolve around the y-axis. If you want to try one extra one, same image, but I'm revolving around the line x equal to 6. Both of them work. This one is x equal to 0. You want to try both of them because we think we'll have just enough time. Yep. No. Oh, x equal to 0. This one. Okay? Joseph, dx or dy? Dx, why? Did you draw? Where's the axis of rotation? Huh? Y-axis, okay. So how are you supposed to draw this again? From curve until where? Curve to where? What line? Random line? I can go to any line I feel like. So what does the y-axis represent? Can you give me a generic way to do every single problem? You draw a segment from the curve to where? What line? Be specific. Because if I went and told the other class, here's how you do it. You draw a segment from the curve to a line. Is that specific enough? No. And I want it to be something that works for every type of problem. What were the exact directions I gave you guys? You make a segment from curve to where? Someone fill in his blanks for me. Matthew? Nope. Listening skills, people. Thank you. Say it again. Say it again. Because I haven't changed my words. I didn't say curve to curve. I have said every single time from the curve that you are given to where again? Okay, so it got repeated 5 times for you. I'll repeat it one more time. From curve to axis of rotation. That is very specific. You don't get to pick where you go to. You don't get to pick top and bottom, right and left. It will tell you. Because you will go to the curve, and you will have to go towards the axis of rotation, which automatically tells you, Joseph, what kind of problem is this one? dy. That is why that's so important. That is why I don't want you to skip this step. This one. Curve to axis of rotation, dx or dy? dy. Once you do that, how should I label this point right here? That's our right side. This one is our? This one is our? This one is our? There's really not much difference. Every setup is exactly the same. You have to follow the way I'm giving it to you, or your pictures are going to be a disaster and it won't make sense. We're following everything from area. I haven't changed how I discuss these since area. All right? The only difference is we're not going curve to curve. We're going from curve to axis of rotation. So for this guy, I drew mine very perfectly. If you're curious, that point is 6, 2. This point here is 2, 0. So my volume, if I'm doing a dy, Tiffany, what are going to be my bounds for this guy? From where to where? 0 to 2. I'll write up both of them for you. Pi, r, this is my r, and for this one, I would have to solve. I get y plus 2 is equal to, I think, squared x. Is that correct? No, y squared plus 2. Oh, yeah. That sounds better. That actually sounds correct. All right. So this guy would be y squared plus 2 minus 0 dy, right minus left. This one used to be a pretty hard problem for a lot of students, but if you follow exactly the same thing, volume is equal to lowest to highest, 0 to 2, pi r, right. What's the value for the right? 6 minus the left, which is this guy. Good. And then squared dy. Can you guys just make sure you have parentheses? Those parentheses are really important. Here they're not important. That's why they're not there. Okay? Are we good? Stay if you need any more help or any kind of anything. Period. Yes. What did I write? Huh?